Hi, welcome to Earl on AI. I'm Earl. We've all heard of the big AI providers in the cloud, Google, Anthropic, OpenAI. They have ginormous data centers and they're building more and more to support their large language models that we use on a daily basis. But did you know that you can run your own local implementation of AI on your own machine? Why would you want to do that? What are some of the advantages? What are some of the disadvantages? Let's find out. If you want access to a premier large language model like ChatGPT, you can have it right now in your browser for a price that ranges anywhere from free to reasonable. If you're a power user that needs more capability, you can have that too. You might pay a little bit more, but if you need that much horsepower, you're probably using it for a business purpose, in which case you're likely to still get a good return on your investment. That being the case, why would you want your own local implementation of AI? Can you even do that? Yes, you can. But before you do, let's start off with a disclaimer. Now, this isn't to scare you off. It's just that I'm an information security professional and I'm big on explaining risks. Most of the software and the models that you'll need to create your own local implementation of AI are free to download and use, but this software is evolving quickly and it's bleeding edge. If you're cautious about the software that you download and run on your machine, and you should be, then just be aware this software doesn't have a long track record. Be careful out there. As a side note, about 25 years ago, Microsoft came out with something that they called the 10 Immutable Laws of Security. And I have always loved law number one, and that is, if a bad guy can persuade you to run his software on your computer, it's not your computer anymore. Keep that in mind as you're working with local AI. So let's talk about the advantages of running your own local implementation of a large language model, an AI agent, and possibly other generative AI applications. First, it's free. The only cost that you're going to have is maybe your computer hardware if you don't already have it, and also your power bill. In particular, if you're exploring the art of programming with AI, which can involve making calls to things called application programming interfaces or APIs, you might save a bunch of money, especially in the development stage, by having your own local implementation of AI. The costs of pay-as-you-go can add up, and they can add up unexpectedly. If your AI programming that you're doing suddenly goes crazy and makes a ton of pay-as-you-go API calls, you might have an unwelcome surprise on your credit card. Even though the use of these large language models can be anywhere from free on up, typically calling the APIs for them isn't free. So again, you might be able to save some cash, especially when you're learning how all this stuff works by using your own local AI server. Also, it's fun and educational. I really enjoy learning how stuff works, and there's nothing quite like downloading the pieces, figuring out how they interconnect, and then making them work that will teach you the ins and outs, what's really going on under the hood with large language models. For me, creating my own chatbot in Python, integrating it with a large language model that's running locally on my machine, and then playing around with it to see how I might be able to make it more effective and efficient, this is just awesome. And finally, it's private. What happens on your local machine hopefully stays on your local machine. Now, you're going to want to read the fine print, understand the configuration settings, look at the documentation for the software that you download and use, etc., etc. Always be cautious. But typically, with a local AI implementation, your data that you're using and your AI that you're using are all local on your machine. And if you want to make sure of this, you could even turn off your connection to the internet, try running it, see if it still works. If it does, then you know you're running local. So why wouldn't you want to run your own AI? Well, first off, the AI that you can run locally will not be as capable as that in the cloud. And by that, I mean by a large margin. All the big providers have ginormous data centers, and their large language models are orders of magnitude more capable than the ones that we can run locally. One way to measure this is with something called parameter count. Now, parameters you could loosely think of like the brain cells of a large language model. It's a crude analogy and it breaks down in a couple of different ways, but it's good enough for now. So parameters. How many parameters do the large language models in the cloud have? It's kind of a closely guarded secret these days, but we suspect in the trillions. Whereas the large language models that you download and run on your own computer are probably going to be in the single digit or maybe the double digits of billions. So again, we're talking orders of magnitude. It's a big difference. The large language model that you download and use on your local computer could be capable, could be fun, but it won't be in the same ballpark as the large language models used by the cloud providers. Also, the amount of computing power that it takes to run your own local implementation of AI might be a factor for you. Your life is going to be much better if you have a decent to high-end graphics processing unit or GPU card in your computer. Your CPU also makes a difference. How fast is it? How many cores does it have? RAM makes a difference. And finally, your storage is going to be important. Your hard drive. It needs to be quick, and it also needs to have a lot of capacity, because these large language models are big, single digit to double digits in the gigabytes. And if you download a few of them and are playing around with them, well, you could see it can add up really fast. Also, there's a learning curve. Using AI in your browser is simple. Downloading and running your own AI software will require learning some new concepts and terminology. I have learned a whole bunch of stuff about large language models, like I was just talking about, the number of parameters, the quantizations, the fine-tunings, what some models excel at more than others. Since I love this stuff, that was a plus for me, but if you're just trying to get something done, could be a challenge. Just know going in, you're probably going to learn a bunch, maybe more than you even wanted to know, about how large language models work. Finally, some of the foundational software requirements can be a little frustrating to navigate. This one package might need a particular version of Python. This other package might need a different version of Python. Python has a feature called virtual environments. They're like sandboxes. They keep your individual implementations of Python nice and clean. And that way, the software that you are installing and the libraries that you're installing doesn't clutter up your main top-level implementation of Python. It's a great feature. If you're going to drill into Python, you should definitely learn about it. And as you go deeper in your exploration of AI, particularly local AI, you probably are going to become more and more familiar with Python. Python's all over the place in the AI world. So just a quick note, in this episode, I'm focusing on large language models, but that's not the only genre of local AI that you can play with, not by a long shot. In the space of generative AI running locally on your machine, there is image generation. That's been around for quite a while. Now we're even moving into the world of local video generation. There is speech synthesis and speech recognition that you can do with local AI in your own computer. And some of the speech synthesis sounds amazing. Like, it really sounds like a human talking, not like the robotic speech synthesis that we've become so accustomed to. Finally, there's audio and music generation. You can make sounds. You can make music. A lot of the same concepts that I spoke about earlier for large language models also apply to these other capabilities. They're free, they run locally, and they're not as good as the free or paid providers that you're going to find in the cloud. And one other thing, the world of large language model local AI has matured significantly, whereas for some of these other capabilities like image generation, video generation, audio, speech synthesis, that kind of thing, sometimes that software is really dodgy. It doesn't work. You have to troubleshoot it. It's been abandoned by its creator a long time ago. There's all kinds of things that you might encounter when you're trying to use that software. So just know it's a little bit of a minefield. Mostly it's safe. I haven't heard too much rumbling in the security community or in the AI community about things that have malicious intent. But if software doesn't get patched, it can become a vulnerability just all on its own. So while those other things are fun, and you could definitely explore them, as I mentioned at the beginning of the episode, always be careful. Know what you're running on your computer. Make sure you're comfortable with it. So you might be thinking, this sounds exciting. What do I need to download and run these large language models? Well, first off, you're going to need some software that enables you to manage this whole process. Downloading your large language models, managing them, and then running them with something called an inference engine. And maybe connecting to them from other software, like things that you write in Python. There are several packages that can accomplish all of this for you. I'll cover a couple of the most widely known, but just know there are other choices out there and your mileage may vary. LM Studio is a very polished package available for Windows, Mac, and Linux. When I downloaded it and ran it for the first time, it asked me if I was a user, a power user, or a developer. Based on the response I gave it, it told me it was going to adjust the user interface with more or less choices. So it was attempting to adapt to my level of expertise. It then allowed me to download a large language model and immediately run it. And there I was in a chat window, looking like I was in something like ChatGPT or Gemini, but all running on my local computer. When you're using LM Studio to browse the free models that are out there that you could potentially download and use, there's a little checkbox that filters the models based on the computer hardware that you have. It's trying to help you to not download something that is beyond your computer's capabilities to run, and I found that to be extremely helpful. Llama is a more lightweight experience. It's also available for Windows, Mac, and Linux. The first time that I had downloaded and used Llama, the interface was limited to command line only. However, as of late, they've introduced a simple looking user interface, so you get a chat box, just like you do with the big players and just like you do with LM Studio. So both LM Studio and Llama, and probably a lot of the other packages that do similar things, allow you to use the capabilities of the large language models with a chat interface, but they also can make the large language model features available to external programs, like a Python script that you write, through something called an API or an application programming interface. Let's say that you were writing your own Python AI agent and you wanted to use a local large language model for the reasoning component. You could do this with either LM Studio or Llama or other software that does the same thing. It publishes its capabilities via an application programming interface. Other software packages can call that API and make use of the large language model capabilities. So once you have the software that enables you to manage all this, you're still going to need one or more large language models. These software packages make it easy for you to download them. But keep in mind, like I mentioned before, they're not small. One that I was playing with recently was actually 18 gigabytes. That was too big to fit in the video RAM that I have on my GPU, but the software that I was using allowed offloading part of the model into my standard system RAM. So I could actually run a model that was too big for my video card, and it still actually performed really well. Now, we already talked about the number of parameters in a model. Often in the file name for the model, you'll see how many parameters it has. Like you might see a 7B for 7 billion parameters, or a 14B for 14 billion parameters. Another thing that you might see in the file name or the description for the model is its quantization. What is this? Quantization is a method to compress an AI model. It uses clever techniques and algorithms to make the model smaller while attempting to retain as much fidelity and capability of the model as possible. A good metaphor would be if you take a giant image file, something like a TIFF file, that has a lot of fidelity but takes up a lot of space, and you use software to convert it to a JPEG file. That JPEG file will lose a little bit of the fidelity. To the untrained eye, the two might look similar or even the same. One is much smaller than the other. The same thing goes for quantized large language models. They're smaller, they lose a little bit of the fidelity, a little bit of the capability, but they'll run faster and they'll run in a lot more places than their unquantized big brethren. There are letters and numbers associated with both the method and the level to which a model is quantized. I would suggest, if you're interested in drilling into this further, looking at some YouTube videos that explore this in some detail. It's actually kind of fascinating, the algorithms that they use to try to make these models smaller but still very capable. So after all that, you might be thinking, which model should I use? It depends. It depends on a lot of things. It depends on which model that week is the best at the top of the leaderboards. It depends on what you're trying to do with it. It depends on the capability of the computer hardware you're trying to run it on. One thing I can tell you, though, is several families of models that are very popular right now, and I think you won't go wrong running any of these. First off, the Llama family of models from Meta are very popular. And yes, that's the same Meta as Facebook. The Mistral family of models from Mistral AI often punches well above their weight. The Qwen models from Alibaba Cloud, that's Qwen, have lately been gaining a lot of steam. DeepSeek, that I mentioned in the last episode, has a whole family of models of various parameter counts. Recently, OpenAI joined the world of free models with their GPT OSS. And also, Llama from Google is a solid contender. That's Gemma. There's so much more to talk about with models. I mean, first off, your use case really does matter. There are models that are dialed in specifically for programming. You might want to use your model for math and science conversations. You might want to use it as just like a virtual assistant or a chat buddy. You might want raw speed, or you might want a model that will answer a little bit more slowly with less what they call tokens per second, but with answers that are more sophisticated and more accurate. Very often you'll find things called fine-tunes, and these can either come from the original creators of the model or they can come from enthusiasts in the AI community. And by fine-tune, what it means is that it is adjusting that model to be good at a particular thing. Other nomenclature that you might see would be base models and instruct models. Usually, instruct models is what you want. Instruct models have been dialed in to answer prompts in a conversational fashion like a chat, whereas base models are more purely just token predictors. You might find uses for those too, including making your own fine-tunes. Often, an instruct model is the one that you want to go after because it's used to answering prompts just like the large language models that you're probably familiar with. And you'll want to pick a model that runs well on your computer, whatever your definition of well is. Again, it could run more slowly and that might be okay with you because you want more sophisticated, more useful, more accurate answers. There's a lot of it depends in this world of which model do I choose, which is why I'm being a little circumspect. It's kind of hard to come up with some sort of consolidated recommendation. You really will need to do your research based on what it is that you want to accomplish with the model, what hardware you're running it on, and whoever happens to have the best thing for that on any given day. So you might be thinking, man, that's a lot to think about. I just want to try something out. Perfectly fine. You can't go wrong with any of the families of models that I mentioned earlier. Llama, Mistral, Qwen, GPT OSS. They're all great. Download one of them, try it, see how it runs on your particular computer. Is it too slow? Is it not giving you the answers that you would expect? And if it isn't to your liking, you can download another one and try it. They're all free. The only price that you're going to have to pay is the amount of space that this takes up on your hard drive. So let's do that. Let's just jump in and play with a couple of these things and see what happens. I'll show you LM Studio. I'll show you Llama. We'll bring up a few different models. We'll play with some different prompts. This is not going to be a thorough walkthrough. This is just playing around like you're sitting at your buddy's house and you guys are looking at this AI software and you're thinking, hey, this is fun. What can it do? All right, well, let's start off with a demo of Llama. I have it brought up here. I've also downloaded a couple, well, 3 actually, large language models ahead of time so that we could save ourselves the time that it takes to download them. If you're downloading something in the 12 to 20 gigabyte range, it can still take a while even with a fast internet connection. So I've done all that for us, and now we can just get in here and ask Llama some questions. This is the default, and as I indicated, a fairly simple interface. We have a chat area here where we can type in our prompt. Over on the left, we have a listing of the chats. I don't have any right now because we're starting fresh. Also, there's a settings button. Now, this isn't a comprehensive overview of Llama. I just want to give you a feel for it. But we will click on a couple of the UI elements in here. On the settings, you have a toggle to expose Llama to the internet. What that means is, say for instance, that you're doing some Python programming, you want to connect up your Python to this Llama for large language model services. You could do that. And that's what it indicates down here, allow other devices or services to access Llama. There's a model location area where you can pick where your models are stored. Also, there's a context length slider that you can use to increase the context or the short-term memory. Also, airplane mode is an interesting setting. If you turn this on, and we'll go ahead and do that actually, that prevents Llama from accessing the internet for any reason, keeps everything local. There are a couple of features that the new Llama has, including turbo mode and web search, and those will actually send things out to the internet. The turbo mode, I believe, will use some Llama backend services to serve the large language model functionality to you. But if you want everything to stay local, you wouldn't want turbo mode. And web search will enable searching the web, which could give you more up-to-date information like the online large language models have, like ChatGPT or Gemini. However, if you want everything to stay local, you probably don't want to do that either. So anyway, we've turned on airplane mode. Now we know that everything that's happening here is going to stay local. So let's start up a chat. And like I mentioned, we're going to walk through 3 different large language models. They're different sizes. They come from different companies. We will ask a couple of the same questions to each of the models and just see how it responds. The first question for each of these is going to be a simple Python programming challenge. So we're going to ask it, write a Python program that outputs the integers between 1 and 10. It's a fairly simple program, should just be a couple of lines. Let's see what it does. Now note how quickly it loaded the model. The model that we're using right now is Llama from Google, and this is a 1 billion parameter model, so it's on the small side. I think on disk it takes up less than a gigabyte. The upside of using a small model is that it's very performant. It came up with this answer just boom. If we take a look at the answer, it looks like it defined a Python function that would print the integers between 1 and 10. The range here ends with 11 because it's always one more than what it's going to count up to in Python. You can take a look at the range functionality in Python to understand why it would be 1, 11. But anyway, that works. It's going to print between 1 and 10. And then within the main area of the Python program, it calls the function that it created. I've noticed that sometimes it creates a function for this. Sometimes it just writes a couple of lines of code to do it without bothering to create a function. Kind of interesting, again, the non-deterministic nature of a large language model. But the other thing that you'll notice down here, it gave us an explanation of what it did and why it did it. And it gives us some instructions on how we could run this code if we want to, and also what the output would look like. So yay, looks like it worked. Now over on the left, I'm going to click New Chat because I want a new context window that is unencumbered by this Python conversation that we're having. So let's click New Chat. And now we're going to ask it a scientific question. Why is the sky blue? And again, because it's a very performant 1 billion parameter model, it's probably going to answer instantly after I hit enter. And it did. And it looks like it got it right. Rayleigh scattering, the sunlight produces all colors, but blue scatters more. Violet actually might scatter the most, but the sun doesn't make as much violet as it does blue, and our eyes are more sensitive to blue. This is why the sky is blue. And I hope that didn't take some of the wonder out of a beautiful blue sky for you, but that is actually the reason why it happens. And it's interesting that Llama even provided a couple of web links down there. I won't click on them. If you click on them, they do work. The links that it provides in the response to your prompt can launch your browser and contact the internet, but Llama won't contact the internet itself. There you go. Let's try this now with another model. Let's go up about an order of magnitude. We're going to use DeepSeek, 8 billion parameters. We're going to ask it the same questions. Write a Python program to output the integers from 1 to 10. One thing you'll notice here is that when I press enter, it will take a couple more seconds to load in this model because this model is bigger. Also, when it is providing the response, you might notice that the speed of the response as it's typing on the screen may be a little slower. The tokens per second may be reduced because, again, we're dealing with a bigger model. Another thing that I wanted to point out, it actually had a thinking process where it reasoned how it was going to formulate the response for us, and then it gave us the response. Let's click on this little light bulb up here to see what it was thinking. It's kind of fascinating. It might be an eye chart test to actually read this, so I'll just tell you it's doing some thinking. It's saying, we're going to use a simple for loop to iterate through numbers 1 to 10 and print each. Alternately, we can use range 1, 11, which gives us 1 to 10 inclusive. Let me write two versions, one using a for loop with range and another without if needed. But the problem says output, so I assume printing is fine. We can do it in multiple ways. However, since the requirement is just to output integers from 1 to 10, we'll choose the simplest way. Version 1, using a for loop. Then after it did that reasoning, it gave us the solution code, which in this case didn't involve defining a Python function. It just went straight to the point and used a for loop to print the numbers from 1 to 10. Interesting. Okay, now we need to ask DeepSeek. And we need to do that in a new chat. Keep our context clean. Why is the sky blue? It's thinking about why the sky is blue. Notice it's doing quite a bit of thinking before it finally decides on how to answer. Gives us the same answer, Rayleigh scattering. Same science under the hood. So now here's an interesting thing. The 1 billion parameter model and the 8 billion parameter model both answered this particular question. It's not a super tough science question, but notice that they both answered it reasonably correctly, or I guess perfectly correctly as far as I know. Right, one more. Let's click on New Chat, and we're going to switch to the biggest model that we're going to use here, GPT-OSS 20 billion parameters from OpenAI. Okay, GPT, show us what you got. Write a Python program to output the integers from 1 to 10. Boom. Might take even a little longer to load this model. 20 billion parameters. I think it might be something like 12 gigabytes on disk. Did thinking, but it looked like it actually did less thinking, less reasoning than DeepSeek did before it kicked out the answer. Give us a minimal Python program that met our specifications. It did define a function to solve the problem. It gave us some explanation on how this particular program works and how we can run it. So, another chat, last chat here in Llama. We will ask GPT, why is the sky blue? And you can actually nearly keep up with the words going across the screen in this particular case. Did a lot of thinking, thought for almost 12 seconds. It also is going to tell us about Rayleigh scattering. In this case, pretty cool. It's going to give us a little mathematical formula here for taking the wavelength of light and the scattering cross-section of that Again, blue has a smaller wavelength, so it gets banged around a little bit more by those pesky molecules as it comes into the atmosphere. And this even gave us a corollary that we didn't ask for, but is interesting. Why are sunsets red if the sky is blue? And that's because the path that the sunlight is taking toward us is much longer than the more direct path when the sun is overhead. So that's it for Llama. Again, just wanted to provide a very brief demo of the application in action. Next, we're going to look at LM Studio. Okay, let's take a look at LM Studio. Again, this isn't a comprehensive exploration of the application. We're just getting a feel for what it looks like, some of the things it can do. In the middle is the chat interface, just like it was with Llama. On the left are some icons that will bring up various features of the application. At the bottom, you can see the version that you're using. You can also see which mode the user interface is in. I mentioned that earlier, that it has 3 different profiles here. If you select the user profile, the user interface becomes a little bit more simple. If you select the power user, you can see that some more things appear. Under developer, nothing apparently changes here, but I think some things do change on other screens that we could take a look at. Let's take a look at some of the rest of these features, these icons. The developer icon brings up a screen with a number of settings that you can use if you're using LM Studio for your AI development, meaning you're using LM Studio as your manager of large language models, your inference engine, etc. We won't cover these at all, just want to let you know that it's there. My Models will bring up a screen showing you the models that you've downloaded. You'll note that I've already downloaded a couple. One is GPT OSS 20 billion parameters from OpenAI, and another is Qwen 3 Coder 30 billion parameters from Qwen. I alluded earlier to fine-tunings. Here's an example. Qwen 3 Coder is a large language model that's been tuned for software development. You can see the quantization level, the size of the model, the date that it was modified, the publisher, how many parameters the model has, and what architecture it uses. Let's look at the Discover screen. These are models that have been specifically selected by the staff at LM Studio as recommended for you to give them a try. I mentioned with LM Studio that it has a filter that will allow you to filter out models that would not run well on your particular computer hardware. If we click on Best Match, there are various ways that you can sort the models that are displayed. How many times have they been downloaded? When were they recently updated? But notice this checkbox only includes staff picks that can fit on my device. My particular computer has 16 gigabytes in the video card, and it has 64 gigabytes of just standard system RAM. That's a total of almost 80 gigabytes. So by checking this box, LM Studio will only recommend to me things that can fit within that amount of space. And you probably wouldn't even want to go with a model that comes close to that, because then you wouldn't have enough system RAM to be running all the other stuff that's going on in your computer. But this is neat. And we will take a look at one of the variants here, GPT OSS 120. Now, a 120 billion parameter model probably won't fit on my device. It's not filtered out because it does take up less than that 80 gigabytes. But we do still get a notice here that it's likely too large. If you download it and try to run it, then it'll be sluggish. Maybe it'll bomb out. So I think this is cool. There's actually a couple different levels here that are trying to safeguard you from accidentally downloading something that will be painful to use. Okay, so let's actually put it through some of its chat paces, because there are a couple of features on the interactive chat that I want to show you as well. So we'll create a new chat. For the model, let's start out with GPT OSS, the OpenAI 20 billion parameter choice. And we'll ask it, one of the same questions that we ask in Llama, we should get a very similar answer because it's the exact same model. Why is the sky blue? It formulated the answer, said it just thought for a brief moment, and now that it's done, we'll just scroll down here. It gave us essentially the same scientific information. I do want to show you now, based on one of the user interface capabilities of LM Studio, what I mean when I say that large language models are non-deterministic. Let's take a look at the very first sentence. The sky appears blue because of a phenomenon called Rayleigh scattering. Down here at the bottom, we're going to click the box that says regenerate message. It's going to use the same prompt and give us another response. Will the response be identical? Our prompt will be identical, so theoretically the response would be, but as you know, large language models have some randomness baked into the way that they operate. So I bet that this first sentence, the sky appears blue because of a phenomenon called Rayleigh scattering, I bet that will be different. Let's give it a shot. So you can see it did some thinking, and you can see that the first sentence of the explanation that it gives us has changed. Interesting. And I can actually prove that it changed because when you regenerate a response, it keeps track of the newly generated response, but also saves the previous generated response. So let's go back to that. Again, first sentence, sky appears blue because of a phenomenon called Rayleigh scattering. Scroll down, go to the second generated response. The sky appears blue because of the way sunlight interacts with Earth's atmosphere. Here's a step-by-step explanation. There you go. There's your proof. LLMs are non-deterministic in the responses that they give you. Both of these responses were probably 100% accurate. This is a fairly simple science question, but they are different. It would probably be different if we ask it again. Branch chat after this message. What this does is it saves this chat as it is, but allows us to create a new chat that also has the history of this chat, so we can kind of continue from here. Let's do that. So we're starting a new chat. We have our existing chat, why is the sky blue? We have a new chat, why is the sky blue, branched. Let's ask it kind of a crazy question. I don't like blue. I want the sky to be orange. How can I make the sky orange? So first off, it politely tells me that you can't change the real color of the sky, but it gives me some tips on how I could use photography, stage lighting, art installations, or even what they call my own backyard sunset to accomplish this goal that I have of making the sky orange. It's interesting, it gives us some of the warmth levels of light, tells us about making a sky dome. It really did nicely humor me here. Now, we can go back to the original chat and notice that we haven't polluted it with the weird orange sky goal. And we could continue this chat from here asking it clarification questions about some of the information that it gave us. Or if we wanted to keep going with this orange sky phenomenon, we can go back over to this chat. We could continue asking it about some of the recommendations that it gave us. Maybe ask for some new details. Anyway, that's kind of cool. Down here at the bottom, there are some other things that you can do with the chat. You can copy the message that it gave you. You can edit the message, and you can delete this message. So let's switch models now. Let's pick the Qwen coder model. So with this Qwen coder model, we're actually going to give it a little bit more sophisticated Python task and see what it can do. write a Python program that will call a freely available internet-based API to provide the weather information for a user-provided US zip code. The program should print the current weather conditions for the zip code that the user specifies. And quite quickly, it gave us a program that uses the Open Weather Map API. We won't go through this Python code in detail other than just to say it does have a try block. It understands that when it's making this internet call that it could encounter errors, like a 404 error if the zip code wasn't found. It doesn't want to just bomb out if it encounters those errors. So it uses an exception capture mechanism to give you the error and not just die. Now, one thing that we could do, we could try putting this into a Python interpreter and seeing if it works, but that's well beyond the purpose of this simple demo. I just wanted to show you that not only can it write programs that can count from 1 to 10 in a programming language, it can write more sophisticated programs. It can give you some additional advice like how you need to install the Python libraries that will be required to make this program run. It tells you that you'll need to get the free API key. Fascinating. Okay, well that was a quick trip through LM Studio, like we had with Llama. We can go into more detail in future episodes of Earl on AI, how these tools work. But just wanted to show you, this is a capability that's running locally. It's giving me pretty reasonable answers. Now, if I ask it a crazy question or ask it to, for instance, quote the entire text of War and Peace or something that it can't do, how it responds to that is a bit of a question mark. I've had certain models that try to do it but fail miserably. Models that instead don't try, they just tell me it's not possible. Well, actually, let's see what happens. Quote the entire text of the novel War and Peace. So good. This one is telling me not only would that be a copyright violation, but that it really can't do it anyway. And I guess it's not telling me that it doesn't have the technical capacity to do it, but I can tell you that the entire text of that novel you would not be able to extract from this large language model. But as I mentioned, it didn't just say no. It said, I can't do that, but here's what I can tell you. I'll give you a little bit of context about the novel. I'll tell you some ways that you can read it if you'd like. And if you'd like to discuss the novel in more detail, like its themes and characters, etc., I can do that. So pretty cool response, actually, in my opinion. All right, that's it for LM Studio. Let's get back to the main video and we'll close it out. So we've only scratched the surface on local AI, and it's my plan that future Earl on AI videos will go into some of these concepts and techniques with a lot deeper dive. For now, if you're interested in learning more about this stuff, there are plenty of YouTube videos out there showing you all the aspects of how to install and use your own local AI. You can go as deep as you want down this rabbit hole, and trust me, it's both fun and it's a time sink. But I think it's really, really helpful to understand how AI works, understand what's going on under the hood, get the underpinnings, and then the next time that you're on ChatGPT or Gemini, you'll have a little bit more insight into what's going on behind the scenes. If you enjoyed this content, please consider giving a like and subscribe, and also clicking on the bell to be notified when a new video comes along on the channel. In the comments, let us know your impressions on local AI. Might it be useful for you? Are there some things that you're interested in playing around with? Would love to hear your thoughts. Thanks for watching Earl on AI. I'm Earl, and I'll see you next time.